Hi, my name is Vanessa Walker, and I'm coming to you with a presentation. I am from actually the APhTI project. I am the founder, president, CEO of the APhTI project. And what I do is I teach, train, and develop pharmacy technicians, and I help them to achieve their personal best. This presentation is entitled The Chemical Symbols That Every Pharmacy Technician Should Know. Elements, ions, and products, oh my. Well, welcome to the APhTI Project's presentation on chemical symbols. You know what? I have 17 years of experience as a pharmacist and about 11 years experience as a pharmacy technician educator. And through my tenure, I've found that there are two things that most technicians are nervous about. One of them is math and the other one is chemistry. But you know what? A basic understanding of chemistry is a good thing. It opens up so much insight into not only other areas of science, but just life in general. But you know what? Don't let me tell you this. Let me show you. So hopefully you got a chance to download the slides that are affiliated with this presentation, and you can follow along. Now, the first or second slide, I should say, is a lexicon and glossary, just some terms that you should be familiar with if you're going to really grasp the concepts that I'm talking about in this particular piece. So first thing is ion, anion, and cation. An ion is a charged particle. Okay, an anion is a negatively charged particle, and a cation is a positively charged particle. So if you want to think of it this way, that the word ion is very general. Okay, it's just a charged particle. It doesn't say whether it's positive or negative. Anion and cation, those are very specific. And an anion is a negatively charged particle, and a cation is a positively charged particle. So if you wanted to just kind of get that hierarchy in your mind, that would be a good place to start. Okay, valence. Valence. Valence, a long A, is the charge that an ion has. Okay, and this is noted above that particular chemical symbol, and it's usually plus or minus. It could be +1, +2, +3. It could be +4. It could be -1, -2, -3, -4. But it's a superscript. So it's above the element. Then we have subscripts. The subscripts are the numbers that are below the element line, and they indicate the number of atoms that an element has. The number of atoms that are in the molecule, let me say it that way. A good example would be if you skip all the way down to where it says diatomic. Diatomic describes a molecule that has two of the same atoms in it. An example would be oxygen. The most stable form of oxygen is O2. So the 2 signifies that there are 2 oxygen atoms per molecule. All right, this is not the same as divalent. Okay, the valence has to do with the charge, and that has to do with the number of electrons in the outermost shell. I don't know if you have done any Bohr diagrams, BOHR, after Niels Bohr, but if you haven't done it, let me just briefly describe. The proton and the neutron are in the nucleus, and the electrons will orbit around the nucleus. And there are different orbits, but instead of calling them orbits, we call them shells. Okay, so in the outermost shell, meaning the shell or the orbit that's furthest away from the nucleus, the number of electrons determines the valence. Okay, all right. Let's go down to atom. The atom is the smallest functioning unit of an element. For our intents and purposes, we're not going to talk about subatomic particles like quarks and and the like. They don't really apply to this discussion. Okay, and lastly, there's molecule. It's the smallest functioning unit of a substance. And if you wanted to get some kind of bearings, molecules are made up of atoms, okay? Molecules are made up of atoms. And then there's something else that is not listed here, but I think it's really important to understand is salt, a salt. Many of us, when we think of the term salt, we think of sodium chloride. And that actually is right. Sodium chloride is a salt. It's one of many salts. And if you really think about what a salt is, if you mix an acid and a base, preferably in equal, that have equal positioning from neutrality, if you look at the pH scale, if you have two that are equally acidic and equally basic, if you can understand what I mean, and you mix them together, the result is water and a salt. And the salt actually has remnants of both the acid and the base, but these remnants are bound together, okay? Alrighty, when we start to talk about some of the elements, you'll understand that a little bit better. At least that's my hope. Okay, when some customary nomenclature issues. Whenever you see a chemical symbol for an element, the first letter is always capitalized, and this is just standard practice. If the element only has one letter, then there you go, right? If it has two or more letters, the first letter is capitalized and all of the subsequent letters are lowercase. So it's really important that you write it correctly, all right? Okay, and I gave you some examples there. The elements that we're going to speak about in this presentation, they either have one or two letters. Okay, so we're not going to deal with any three-lettered elements or ions. Okay, so let's begin. H. H stands for hydrogen. Okay, whenever you see H plus, that means proton. A proton is a positively charged hydrogen ion. Now, hydrogen is very, very important when we start to talk about the differences between acid and base. And I kind of referred to the pH scale before, but other than a substance having a pH of less than 7, defining an acid, and a substance that has a pH of above 7 being definitive of a base, what exactly drives that? Well, it has to do a lot with hydrogen. Hydrogen, or I should say more specifically, the proton, because it's the ion that is at play here. Whenever hydrogen ionizes, it's always positive. And what defines an acid, or one of the parameters, is that an acid will readily give up a proton. So an acid will readily give up a proton. A base will readily accept a proton. Okay? And that's just one set of parameters of what defines an acid, what defines a base. When we get to oxygen, I'll have more to say on this topic, but I don't really want to put the cart before the horse at this particular juncture, so let's move on. The next element is Li, which stands for lithium. Please don't confuse lithium with a pharmaceutical product, Librium. Now, both of those, lithium and Librium, are used separately in areas of psychiatry. But lithium is the element, okay? And it's important because it is used medicinally. People with bipolar disorder, they use a drug sometimes. It's an old drug, but sometimes you'll see it, lithium carbonate. And LiCO3 is the chemical nomenclature. So that's why lithium is important. Lithium is in the family, and I didn't talk about this before, and I meant to, that all of these elements come from the periodic table. And when you look at the periodic table is arranged by family. So you'll have things like the inert gases, that's a family. You have the alkali metals, that's another family. And the reason that I bring this up is because lithium and sodium are in the same family. And a lot of times when a person has issues with their sodium level in their body, they can't really, lithium doesn't act right. Lithium is not a good choice for someone that has high sodium because lithium and sodium will exchange for one another, and that's not good. A person can build up toxic levels of lithium. Okay, I'm going to take a short recess, and I'll be right back. Okay, so I'm back. So we were talking about lithium. That was the last element that we spoke about. Okay, so the next element that's on the chopping block is carbon. Carbon, the chemical symbol is capital C. Carbon is very important. Aside from the fact that diamonds are made from triple bonded carbon, uh, graphite is double bonded carbon. Aside from those facts, carbon is important because we are carbon-based life forms. And there's a whole branch of chemistry that deals with carbon and its interactions with other compounds. And that branch of chemistry is called organic chemistry. It's called organic chemistry. So, oh my goodness, how much chemistry have I taken? Years of chemistry. Ah, fun times, fun times. I realized that I had a love for chemistry when I was in high school. I made my own soap in the chemistry lab and I was hooked ever since. Okay, moving right along, enough about me, to nitrogen. Nitrogen is very, very, very important. Um, Nitrogen is actually in the air that we breathe, but we can't absorb it from the air. We have to get our nitrogen intake through our diet, protein. Proteins are nitrogen containing compounds. Um, you may have heard of nitrates, things like nitroglycerin. Nitroglycerin is a very, very effective explosive, but we use it in small doses for people that have angina, which is a tightening of the aorta, and it's used as a vasodilator, so it opens up the blood vessels. Um, don't get nitrates confused with nitrites. Nitrites are the preservatives that you find in cured meats, like cold cuts. Okay, nitrites have been tied to cancer. Next, we have nitric oxide. And it's interesting that the nitrates, when they're used as vasodilators in the body, they actually get metabolized to nitric oxide. Okay, nitric oxide is also it's endogenous, which means that the body makes it. It's found in the body. Okay, it's endogenous. Nitric oxide is a very potent. Nitric oxide is a very potent vasodilator. Okay, and it helps to keep our organs healthy so that they can get enough blood flow. Okay, then we have N2O, which is nitrous oxide. You may be familiar with this from the dentist. It's also nicknamed the laughing gas, that sweet smelling gas that they give you to make you lose the sensation of pain. Okay, then we're going to go to BI. Remember, capital letter B, lowercase I. Bismuth. Bismuth is important because there is a salt of bismuth that is used medicinally. And when you hear the word bismuth, you probably think of Pepto-Bismol. Right, and Pepto-Bismol is used medicinally, for stomach ailments. Remember, it coats, it soothes, and it relieves. This salt, and the chemical symbol is there, C7H5BiO4, is bismuth subsalicylate. Please be aware that bismuth subsalicylate is in Pepto-Bismol for adults. It is not in the pediatric product. And there's a very good reason for that, because anytime you see salicylate in a chemical compound, it means that it contains an aspirin-like moiety. So it's frowned upon to give children aspirin, especially when they present with fever, because there is a strong link to Reye's syndrome. Reye's syndrome is not a good thing to have. It actually causes fatty deposits to form in the liver and the brain. Not good. Okay, so don't give children aspirin or anything that has salicylates in it. There's other compounds that have salicylate. Oil of wintergreen is methyl salicylate. So those things, even like icy hot, is not a good idea. Okay? The absorption is probably lower through the skin, but the presence is still there. So just be aware of that. A little bit off track, but I think it was beneficial. All right, let's go on to oxygen. The chemical symbol for oxygen is O, but the most stable form of oxygen is its diatomic form, which, remember, it's two oxygen atoms in the same molecule, and that's signified by O subscript 2. There is also something called ozone. Ozone is O3. Ozone is highly unstable. It's not stable. And when we have this ozone layer that I'm sure you're familiar with, and O3 will actually dissociate, meaning that it breaks apart and comes together. It breaks apart and comes together in this kind of cycle. So that's why you see the two arrows pointing in different directions, because that signifies dissociation. So it breaks apart and then it comes back together. And this is a cyclical thing. But it breaks down. When it breaks apart, it forms O2, which is the most stable form of oxygen, plus O minus. And this O minus, remember the negative has to do with the valence. This is a negatively charged oxygen ion, right? And it's an anion. And what is important about this, we don't know, most of us don't know it by that description, but most of us know what a free radical is. And we know that free radicals have been tied to cellular damage, right? The O negative is your free radical. Now, the thing about a free radical is it's always looking to cleave to something. It's always looking to complete itself. So the free radical is always looking to complete itself. I usually, when I teach this topic, I liken it to people. There are some people that can't be by themselves. They always have to cleave onto other people because they don't feel complete. Those are similar to free radicals. If you can understand the person analogy, then you can understand what a free radical is. And this is one of the reasons why, well, the reason why it causes cellular damage. But there's also something else that that makes this so significant. When we used CFCs, chlorofluorocarbons, in the aerosol cans, what would happen is, because when gases mix together, they'll diffuse. They'll diffuse through the air. So when you release a gas, any gas into the air, it will diffuse through the air, and it will get less and less concentrated the more time is allotted, right? So what happens is, because these CFCs are light, they diffuse through the air, and what they do is they end up in the ozone layer. And they will wait for this dissociation to happen, and the free radical and the CFC will actually bind to each other. This creates a problem because then it destroys ozone. So the government recognized that this was an issue and changed, well, actually enacted a law that the aerosol propellant had to be something else other than the chlorofluorocarbons. Now, what has been used, at least pharmaceutically, is something called HFA. HFA stands for hydrofluoroalkanes. So they now use hydrofluoroalkanes as the propellant for these aerosolized drugs. And that's the reason why, if you remember way back when, drugs like Proventil, you would have Proventil. And then when this law became effective, they had to change the form, well, not really the formulation, just the propellant to hydrofluoroalkane. So now you have Proventil HFA if it's the aerosolized canister. Okay, and that's the reason why you see all of these drugs, aerosolized drugs, as HFA. The HFA stands for hydrofluoroalkane, and that is signifying that this is not the chlorofluorocarbons that were damaging to the ozone layer. All right. Okay. And next is OH minus. And OH minus is the hydroxide ion or hydroxyl group. Either one is correct. And remember when I told you that when we got to oxygen, I would tell you a little bit more? Well, here we are. Because going back to acid and base, and remember when I told you that an acid will readily give up a proton? Remember that? And I said a base will readily accept a proton. Well, guess what? An acid will readily accept a hydroxyl group, and a base will readily give up a hydroxyl group. Okay? OH negative. That is what defines a base. And if you really understand when you add, a base and an acid together of equal potency, why you get water and a salt. See, you get the proton and you get the hydroxyl. Water is H2O. It's two hydrogens, right? And it's one oxygen. So you have the proton, which is a positively charged hydrogen ion, right? And then you have that hydroxyl group. You have the hydrogen from the hydroxyl group. Those are two hydrogens right there and one oxygen. So that's why you get water. And the remnant of the acid and the remnant of the base will actually bind together. Okay, and that is what your salt is. So if you can understand that, you'll understand why you get water and a salt. Okay, let's go on. This is really exciting stuff. I love chemistry. Oh my goodness. Now we get to F. F is fluorine. Now, most of the time you will not come in contact with fluorine. Oh my goodness. Molecules that contain fluorine are usually highly reactive. So this is not something that you're going to come in contact with, really. But you will come in contact with fluoride. Fluoride is the ion, right? It's negatively charged. And you know that fluoride is used in dentistry, right? You get a fluoride treatment every now and again. And it's also in our water, right? And it's in our toothpaste. And they found that having fluoride actually prevents cavities. It's an interesting story how that came to be. I'm not going to go into that here because we don't really have the time, but if you ever get a chance to really research that, oh, it's just fascinating stuff. Fascinating. Okay, next we have Na. Na is the chemical symbol for sodium. And you're saying Na, sodium, Na, so how did that come to be? Well, the Latin name for sodium is natrium. And the chemical symbol comes from the Latin. You know, I remember back when I was in the 7th grade and I had a teacher. His name was Mr. P. Well, I'm going to call him Mr. P. And Mr. P made us memorize all of the elements on the periodic table. And the ones that had a Latin origin, we had to memorize both the English name and the Latin name. And, you know, at the time, I felt that I had a love for, knowing about these elements, but I really did not understand how important that would be in my life. Oh my goodness. So thank you, Mr. P. I don't know where you are now, but thank God for you. Okay. So you know that sodium is in table salt, right? Sodium sodium by itself, not in salt form, is highly reactive. I mean, many times they will keep sodium in liquid. It will react with air and it will react violently with water. So they'll keep it in kerosene so that it doesn't explode. It's highly explosive. And when we get to chlorine, chlorine is a poisonous gas. They bind together as sodium chloride and we sprinkle it on our food. Isn't that something? Just something to think about. Something interesting, I think. All right, so we're moving right along. Next, we have AU. AU, which is gold. And I remember it this way. Pirate says, AU, give me your gold. AU is gold. Keep it very, if that helps you remember it, is what I'm trying to say. If that helps you to remember it, then use it, because the symbol for silver is similar. Silver is AG. Gold is AU. AU, give me your gold. Gold is more precious than silver, right? Okay. Now, when I was a child, I used to think, or, it was told to me that gold is non-reactive. That is so untrue. Gold is reactive. It doesn't really react easily with a lot of things. A lot of times they have to use hydrocyanide in order to actually cause it to ionize. So it's a multi-step process that they have to use. in order to have gold ionized, but it can ionize. And there are drugs that are gold salts. A lot of them are used in the treatment of arthritis. Now, obviously, they're not first-line agents because gold is pricey, but still, it does exist. Now, when gold has a valence of +1, it's called aurous, and when it is +3, it's called auric. But you're saying Au, where did they get that from? Well, the Latin word for gold is aurum, and it means something like morning sunshine or light at the break of day. It's really a beautiful, beautiful name, aurum. Aurum is gold. Next, we have Mg. Mg is magnesium. Magnesium is important because, for a couple of reasons. You need magnesium in order for your heart to function properly. Magnesium is an excellent, salts of magnesium are excellent muscle relaxers. So you'll find magnesium sulfate is used in obstetrics, in gynecology, for women that are in labor. Sometimes they'll give them magnesium to ease the contractions. Excuse me, I'm getting over a cold, so, excuse me. Let me drink some water. Okay, that's better. So they'll use magnesium in obstetrics. They'll also use magnesium in antacids, those things that combat indigestion. They'll use magnesium, a magnesium salt, and they'll also use an aluminum salt together. And magnesium, when it's taken into the digestive system, is notorious for causing diarrhea. They put it with aluminum because aluminum is notorious for causing constipation. And the net effect, at least as far as the bowels are concerned, is zero. They cancel each other out, is what I'm saying. All righty. Plugging right away. And look, Al is aluminum. Whenever aluminum ionizes, as well as when magnesium ionizes, they both are divalent. So they have a charge of +2 as their valence. And again, a lot of antacids contain aluminum. The thing is that not everybody can tolerate aluminum. People that have poor renal function, renal means kidney, people that have poor kidney function really should stay away from aluminum containing compounds because they can't excrete it well, and it will start to build up in your system and cause all kinds of problems. So yeah. I think that's all I want to say about aluminum. Well, aluminum containing compounds are sometimes used as astringents. Antiperspirants may contain it because of its drying effect, either aluminum or zinc, because zinc also has a very drying effect. It has an astringent action, and what an astringent does, it just pulls the moisture out of tissues. So it's very drying. All right, moving right along. Moving right along. My brother just came in. Moving right along to phosphorus. Phosphorus is capital letter P. Okay, you will rarely see phosphorus by itself. And phosphorus is an interesting element anyway because it it exists in like 4 different stages or states. When you see phosphorus, it will be part of the phosphate ion, which is PO4, and it's negatively charged. The phosphorus and the oxygen together work as a unit, and that whole thing, PO4 negative, is called the phosphate ion. Okay, let me just make sure that I've told you everything that I want to tell you about phosphorus. All right, next is chromium. Chromium, Cr. Chromium is a trace element. So what that means is that your body requires it in very small amounts. It's required by the body in small amounts, but it's still required. People were using chromium to lose weight. They were using high doses of chromium to lose weight. So in case you come across it, that's what it is. Cr, chromium. Next we have S. Next we have S. And S stands for sulfur. S stands for sulfur. And sulfur is interesting. They're all interesting to me. But what is interesting about sulfur is that your sulfur-containing compounds usually have a smell. Sulfur smell is the smell of rotten eggs. For those of you that read the Bible, when we talk about brimstone, this brimstone has sulfur in it. So brimstone is really smelly. It's a sulfur-containing compound, okay? But you probably won't come in contact with pure sulfur. You will come in contact with the sulfate ion, which is SO4 with a negative charge. And just like phosphate is PO4 with a negative charge, in sulfate, the sulfur and the oxygen act as a unit, okay? It is one ion. 2 elements make up one ion, okay? And you may be familiar with sulfide, okay? And that is a sulfur that has a valence of -2. The sulfide, in DNA, you have these bonds that connect it, and these are sulfide bonds, okay? So that is why sulfur is important. Next, we have potassium. Potassium is K. Potassium comes from the Latin word kalium. That's why there's a K instead of a PO, right? K is potassium. Potassium is important for the heart to beat properly. And you have a lot of potassium in your cells. You have intracellular potassium and extracellular potassium when it comes to your cells. So potassium is important on a cellular level. And it sounds like kale, doesn't it? Kale is touted as being high in potassium. Isn't that interesting? One of the things I tell my students is words tell you what they mean. And it's just that the mystery may be in another language, but they tell you what they mean. All right, we're going to move right along to Ca. Ca is calcium. It ionizes divalently. It's divalent when it ionizes. So it's Ca with a charge of 2 plus. Calcium, as you know, is important for healthy bones and teeth. It is also important for heart health. And it has a relationship with magnesium. Calcium is one of those, it needs a perfect storm in order to be absorbed. Yes, so calcium needs a perfect set of circumstances in order to be absorbed properly. It needs to be in an acidic environment. Vitamin D will help in the absorption of calcium, so vitamin D is very important. And it also needs magnesium. The presence of magnesium will help calcium to be absorbed readily. There's a class of drugs called the calcium channel blockers that are used in the treatment of high blood pressure. And that's of note here. Okay, and we have zinc. Zinc ionizes as divalent. Okay, zinc ionizes as divalent. So you have a Zn with a 2 positive valence. Once again, zinc containing compounds they have an astringent action. They're very drying. There's a whole product. Well, I said, it's not really a product line because they have other products that come underneath this name, Desitin. But original Desitin is it is milky white. It's opaque white, and it's used for diaper rash. And it's an excellent product because it is very absorbent. It will keep the baby's bottom from being from breaking out in rash because it forms a barrier. That plus of the drying action of the zinc makes it really an excellent product. But people use zinc oxide in the summertime. On the beach, when you see those muscle people and they're playing the sports and volleyball, and you look at the tip of their nose and they have something white, a lot of times that's zinc oxide. Zinc oxide is an opacifier, and what that means is it keeps the harmful rays of the sun from penetrating and causing damage to the skin. So zinc is also used for that purpose. You have zinc lozenges also that have a very drying effect when it comes to drying up mucus. Zinc is, I said it's a great astringent. And okay, that's all I have in my notes to tell you about zinc. But for some reason, I'm feeling like I'm forgetting something. Okay, all right. So we're going to move on. It'll come to me. There are so many more elements that I want to speak to you about. And what I'm going to do is I'm going to put this as a part 2 because I am currently on slide number 20 and I have 32 slides total. So I am going to put this as a part 2. What I will say is, if you would like to contact me, if you would like a copy of the slides, I can send you a link. My name is Vanessa Walker. I am a pharmacist and pharmacy technician educator. I'm also the founder of the APhTI project, soon to be published author. I have a website. My website is www.theaphtIproject.com. That's TheAPhTIProject, all one word. You can also email me at vw@aphti.com, and you can visit my Facebook page. And if you like what you see, please like my page, facebook.com/The APhTI Project. That's TheAPhTIProject. I have a newsletter that I put out twice a month. So if you're interested in that, please visit my website and sign up for my newsletter. Okay, thank you so much for watching my video, and I hope that this information is beneficial to you. And stay tuned for part 2. Part 2, I'll probably deliver in a week or 2. If not next week, then the following week. But like I said, every week in February, I'm going to talk about something that has to do with pharmacy and something that has to do with, technicians and helping technicians get better. All right. Thanks. Bye. Make it a great day. Be blessed.